So we're going to look at how to transpose simple formulas. Transposition. Sometimes we need to change the subject of an equation or a formula. So the term we use for this is transposition, simply meaning to transition or change the position or location of something. In our case, it's going to be the subject of the equation. Transposition allows us to make the quantity that we're trying to find the subject of the equation. The number one rule of transposition is that whatever we do to one side of the equation, we must do to the other. This is an example using Ohm's law. A simple example is the voltage current resistant triangle. V equals IR, or V equals I times R. These are both the same equation, we just don't show the multiplication symbol when we write them like this. So it would be shown as V equals IR. I've added the multiplication symbol in to show you where it should be. If we want to find out the resistance, making R the subject of the equation, we must. First, we divide each side by I. This gives us V over I equals I times R over I. The two i's in the second half of the equation cancel each other out. I over I would equal 1. So we can remove these from the formula. This would leave us with V over I equals R. So what we do now is we can swap the right hand side and the left hand side of this over to make R the subject, which is R equals V over I. So to find the resistance of a circuit, we can divide the voltage by the current. Example number 2. So making T the subject of this equation, V equals U plus AT. Again, the A and the T are next to each other, therefore they are multiplied together. There's just no multiplication symbol. So start by subtracting U from both sides of this equation. V minus U equals U minus U plus AT. As U minus U is equal to 0, we can reduce the equation to V minus U equals 0 plus AT. We can then reduce this further to V minus U equals AT. So now what we need to do is divide both sides by A. V minus U over A equals AT over A. As A over A equals 1, this then becomes V minus U over A equals T. Swap the right hand and the left hand side of this equation to give us T equals V minus U over A. And we've now made T the subject of this equation. So if we had the values of V, U and A, we'd simply take U off of V and divide that by A, and that would give us the value for T. Example number 3. Make V the subject of the equation. So H equals V squared divided by 2G. Start by multiplying both sides by 2G. So H times 2G equals V squared over 2G times 2G. Now 2G over 2G is equal to 1, so the equation should now look like this. H times 2G equals V squared. So now we need to take the square root of both sides. So that would give us V squared, the square root of V squared, equals the square root of 2GH. And since the square root of V squared is V, we find that our equation will be V equals the square root of 2GH. So these are the references where I got images and information from to make this video. And this is the book that I've been using. So example 2 and 3 are both taken directly from this book.